of the talks from Ted, who came all the way from LA, who is hopefully going to be headed back to LA if he can get out in the snow. So they are just over there. Buy them for cheap. So last but not least, you're here to see Scott Moulton, and he is going to talk to you about DIY hard drive diagnostics. Enjoy. Give him a hand.
Everybody hear me okay? Yeah. Check, check. Everybody good? Okay. And I'll have some sounds and stuff I'm going to play off my laptop today, so it'll be the first time I tried to do that at a con, I think, other than if anybody saw my recover porn from Ray to Ray. Anybody see that one? Yeah? Where I'm juggling, there's like porn going on? Yeah? Okay. All right. Anybody seen any of the other videos and stuff I've done? It's like my 4th or 5th year here at Shmoocon. Anything? Yeah? Everybody good? All right, so my intent here is to kind of make like a series of videos that when you watch them in order, that it will be like this epic adventure for data recovery that you will know how to do some, 80% of the drives by yourself without having to send them off to a data recovery company. And of course, I have data recovery companies that are pissed off at me for this, so I try to get straight to the meat and potatoes. I don't want to spend 35 minutes talking about a VMware DD image, so just in case you want to know. So ultimately, I have some goals for this talk. The first thing is obviously, who the heck am I? Why is this Charlie Brown looking guy up here, trying to tell you about data recovery? I do data recovery for a living. I own a company called myharddrivedied.com, which has been around, thank you. I have like 50 hours of video out there that's free, that's published, all on in-depth stuff. It's not fluff, it's not crap. It's the real stuff. So if you want to go look at how to do RAID arrays or whatever else, I have demos and everything out there. And it's not like marketing crap or anything, it's real shit. So that's the first thing. I also run a forensics company side by side. We do alternating work between the two. So I do a lot of forensic work, a lot of data recovery jobs that are damaged drives in forensics cases. So if you want to know some more, go to those. But I also teach classes. So if you like what I'm going to do in an hour, well then, if you want more and you don't want to wait for the next con, because it's a series of events over 5 years so far. The next one's going to be in Outer Zone next month in Atlanta. March 20th. So I'll have some cards and stuff up here for Outer Zone. If you guys want to come up and get one, you'll find out where it is, what it is. It's a small con, but I'm going to be doing a new talk there next month on data recovery. So the first thing is I want to make sure that when you walk out of this room, you at least know something new. Not like anyway, just want to make sure you know something new you didn't know. So hopefully everybody will know something when they walk out of here, and hopefully a whole lot. Make sure that you know when to stop doing data recovery. That's my biggest problem now is I've done this series of events where I started at higher end stuff. Now I'm actually going backwards. I'm going back to the beginning and saying, look, this is stuff you should have known in the first place before you got to the other advanced videos because of the emails and stuff I get on a daily basis now. Oh, I took the platters out or I took the heads out and I want to replace them and it's too late now. Sorry. So I want to make sure you know when to stop and say, look, I can't do this problem. And I give you specific examples so you know why. This is obviously about as cheap as possible. So this is not about I bought a $15,000 tool and here's how to use it. I will give some quick, short examples of what the difference is, but ultimately the whole point is I'm trying to teach you how to do a lot of your own stuff without having to spend, even in excess of $100 if you can avoid it. And then I'm going to tell you about some things that suck, that get in our way. So there's lots of ugly text in this speech. If you want copies, they're already posted. I do not expect you to remember everything I say, so like flowcharts and stuff that I have up here that are really ugly, I've already posted on my site. So if you go to myharddrivedied.com/shmoocon.html, it's already there, PDF, ready to go, download it. You can look at it now if you want. But that way you don't have to remember. And if you don't remember shmoocon.html, then you just go to myharddrivedied.com presentations and it's at the top. So it'll automatically be there. All right, so anyway, so this is the basics of what I'm trying to cover today. Like, these are the 5 major issues that you have to deal with when you're dealing with a hard drive and you want to know what's wrong with it. A lot of people will go, plugged in the hard drive, I don't get any user data. So what happened between there and not seeing my user data? That's what I'm focusing on here. So do you have a firmware problem? You got head damages, boards are problems, motors, things like that. Where do you start? Where do you stop? And then do I actually have platter damage? So it's not always going to be this obvious, okay? This is obvious, and if you're doing this, we're going to be dealing with either some soldering. You can't just swap boards in some cases, and there are going to be some chips and stuff that you have to solder in certain cases. There are certain drives that you can just swap boards, but we're going to talk about those. So I can't just jump straight into diagnostics. I got to back up a step and have to say, hey, look, what do you know now, and how do you sort of derive what these things are, especially if you don't have any fancy tools? So keep in mind there are these fancy tools. You can just plug stuff in, and it tries to give you like a summary of what's wrong with the drive. And you still have to know something. It's still not like completely like, here's one button, and it comes up and tells you, oh, I got a firmware problem or something. You still have to know quite a bit to make that happen. So in 10 minutes, I'm going to try to make just kind of like a, and it may be 15 minutes, I don't know, you know, a little bit of a basic idea about how we're dealing with what type of problem. So the first thing is, if you have a hard drive and it's dead, the very first thing that happens is somebody goes, oh, I want to swap heads. I think it's a head problem. I want to swap heads. I'm trying to stop you before you get that far to say, let's don't swap parts. Even boards, you have to be very careful with going buying an identical drive and then swapping the board. And I know I've said that in some previous events, but some newer things have come out lately that can cause damage with the boards. And in certain drives like Western Digital's, you may need to unsolder a chip and move it. And it may not do damage if you swap the board, but it's not going to work either. So without that, you need to know that. So I want to make sure you know, if you're thinking about swapping parts, when do we actually discuss that? Where are we actually going to talk about practicing with the drive? And I get these emails all the time too. I got this one drive in from my client. It's not working right. Where do I buy a donor drive so I can swap heads? This is not like in 5 minutes I learned how to swap a head. It's not easy. This is like go get a dozen hard drives and go play with them and figure out how to do it first and make it work. I do not want to, you know, in any way, shape, or form tell people you don't need to practice. I mean, that was never the intent at all. It was always go get a dozen drives, rebuild a working drive back to a working state, and then you might actually be ready to do that. But don't do it on the client drive. They always practice later. Like, oh, I tried that, now it doesn't work, and now they try another drive, and it's too late. So anyway, so that's what we're trying to do. So over the years of doing data recovery and going through this process and then developing a class that, you know, I do teach at like, you know, some FBI agents and things like that, teaching a class, I basically have these 5 steps. And there's this one that loops back. So in the diagnostics process, I end up looping back like, hey, if it works, we're already in the process of imaging and copying sectors. And if that works, we continue on. But if not, then we're going to repair the drive and we're going to start all over again and loop back through this particular process. So what our goal is, primarily, is imaging. Now, I know a lot of you are, who's done forensics imaging? Yeah, you're all doing it wrong. All right. Well, not you. Okay. He's not doing it wrong because we've been educated. So anyway, so ultimately the point is when you do a forensics image and you use something like, I don't know, DD, FTK image or whatever, when you're doing an image and it gets to a bad sector, what happens? What is it? Yeah, it either stops and dies, or what does it put there if it's able to continue? Error. Zeros, right? There was data there, right? There was data there. So if you got 512 bytes, and let's just say one is wrong, if you could still get the rest, that doesn't make the rest wrong, right? So there's still a process in which you do not have to pad all of that data. There's still a couple of things that you can actually do to read from those damaged sectors. So if I'm able to do that, say ignoring ECC or getting some other content back and filling those sectors, and it's not 0, it's got to be better than 0, right? The other problem with 0 is that 0 doesn't indicate anything different than the rest of the unallocated space on the drive that was 0 in the first place. So unless you're writing like bad, bad, bad there, you don't know the difference between what was a bad sector and then what you need to fill in versus empty space that was already 0 in the first place. Not that it's always 0, because sometimes there's just unallocated crap out there that you got to recover from. But ultimately, our point is we got to stop thinking about files. For the most part, I want to forget about files, and I'll kind of show you some cool stuff that includes files. But ultimately, I deal with sectors. So this way, I don't have to care if it's an encrypted drive. I don't have to care if it's, you know, what is on the drive or what OS it is. I can almost always deal with the sectors. Even if I'm doing an AS400, like anybody know what size? Like everybody knows, you know, the physical size of a sector is 512 bytes. Anybody know what size a sector is on an AS400? 500 what? 522. It's 522. So the other 10 is ECC stuff in there that you can just strip out. But what happens if you hook up 522 byte hard drive to a write blocker? What is a write blocker? Anybody know? What is it? A write blocker is a piece of hardware with software running on it that then intercedes so that it can pass that along. So the first thing that's going to happen is it's going to lock up or crash. You won't get a response from your write blocker, but it doesn't mean you can't copy those sectors. So I'm just making an example here that there's actually ways that you can actually go through this imaging process dealing with sectors. Forget about files and other stuff. It doesn't matter what you're dealing with. So let's get rid of this crap. These are things that suck. So we're going to talk about these things that suck and get them out of the way first. So a lot of the imaging tools, the things like vendor tools, microscope things, software repair tools, the freezing, a drive, ATA components, smart, things like that. Those all suck. So what is wrong with these things? Huh? Cost money? Well, that's true. They do cost money. But besides that they cost money, what else is wrong with them? Is there anything really that different amongst any of these products? I mean, they all basically do exactly the same thing. But what are they all going to do when the drive fails?
Ruin your data.
Ruin your data. Maybe. It's possible. They're going to fail too. Almost all of those tools that are imaging things, when they actually hit a damaged disk that has more than a couple of bad sectors or something, they usually fail too. And they may even fail only on one bad sector. It may show you a little thermometer. It'll go across. It'll read where there's a bad sector. And then from then on, you'll just get this file that was full of zeros that a thermometer told you I was done, but not really have any data. So they typically fail on those drives as well. So almost all of those just like off-the-shelf commercial imaging products with a few exceptions. But for the most part, they will fail. So there are more robust, free / even some expensive ways of doing this so that you can actually be talking to the drive with bad sectors and still be able to copy stuff. There's some simple things that you could do like read a drive in reverse with PIO mode. You may actually get sectors that could not be copied other ways for free. There may be a way to do that. Usually you have to have a tool to redirect that. So there's a lot of these that I have in the top like MyRescue, HDDiag. Those are free tools, Linux-based. Then there's Media Tools Pro, that's a Windows tool that's actually fairly expensive, like $300 or whatever. Speed Clone's like $40. Those will read drives in reverse and do a couple of different things. And there's a couple of dozen tools out there if you search for them correctly that you will find. And then there's even like the Ultimate Boot CD, which has some helpful tools on it. The important one to me that's on the Ultimate Boot CD that's free is MHDD. Because with MHDD, it's actually doing diagnostics where it bypasses, in some instances, the BIOS talks to the ATA controller. So even if your drive doesn't show up in the BIOS itself, you may still be able to communicate with the drive, scan it for bad sectors, or spit stuff out to a file, sectors to a file, so that you can actually parse them and do other stuff. So there is some possibility of talking to your ATA controller, bypassing your BIOS, because basically the BIOS that's on your computer does a very stupid thing with regards to drives. So there are other solutions with hardware, even some what I call low-cost solutions, but they're not cheap. The Deep Star Disk Imager, PSI Clone, other things that are forensics tools where people are already spending like $1,000 to $2,000 on TDIs or VOOM hard copies and stuff. Those really don't recover from bad sectors either, but there are tools that do forensics images that do recover from bad sectors. But I'm going to give you just a quick example. This is a small video, and basically what's going to happen is when FTK Imager or any software or anything is going forward on a drive, in a lot of cases it will fail because of problems with, like, for instance, cache on the drive. I covered that in some other talks, where cache is caching in advance on the drive, and if it hits a bad sector, it's either going to skip it, fail, or do whatever, and you're going to get chunks of data that it can't read, and most of the time, FTK Imager or any of the tools based on DD will just fail and never recover. And so this is a tool, this is a piece of hardware that's kind of like a BitTorrent. It doesn't care where the sectors come from, it doesn't care what order that they're in, but it'll go forward and try to read the sectors that are good as fast as it can, but in reverse, it will try to read the ones and fill in the holes of the sectors that were bad that it couldn't read the first time around, filling in those holes as it goes. So you're going to see from this. So, and I actually get a display in hex as it's doing this. All the brown ones are ones that were going forward that it failed. And so now going in reverse, I'm actually able to fill in these holes and actually see that in hex as it's going by, fixing a lot of the things in the disk. Now this particular tool is called the Deep Star Disk Imager. There are some ways to do this in software, like HDDiag tries something very similar in Linux. If you understand how to use the tool and do what you need to do, you may actually be able to accomplish this. Unfortunately, in most cases, it's not like spitting this out in hex, giving you some good feedback or something, but you can play around with it. But this is just an example of ways to actually get around that problem. So when you're dealing with other tools like microscope and the vendor tools, like anybody run like C tools or anything on their stuff? Anybody ever run that? Like, what does it tell you on your bad hard drive? What does it say? What?
It says it failed the test.
Yeah, it says fail the test, and it gives you what? Just like a generic number, right? It just says 523. Have you ever called tech support and asked them what that meant? What do they say? They go, oh, that's a generic error. We don't know what it means either. Just send it in. It's under warranty or something like that. That's about the best you get. So most of the time, those tools won't tell you very much either. Very few of those tools will actually give you like a real indication of what's wrong. Same thing for a microscope and the other tools where you pay several $100s for a tool to examine your drive. They only are meant to work on working drives. They really don't work very well on damaged drives. It won't come up if you can't get it to actually initialize. What is your problem? And they are not going to help you out. So skip most of those things. They're not going to do a lot for you. Same thing here. You always want to save the state of your drive. You do not want to be messing with the drive in instances where a check disk, fixed disk, or anything else is going to make changes to your disk. I also remove SpinWrite from my list from a standpoint of don't use it because it makes changes to your original drive. It does not write to a destination disk. It may do the proper thing. Unfortunately, it doesn't write it to another disk. So if that disk dies or there's further damage to the disk, it's the last time you ever saw it. So unless they are going to change this to write to a destination disk, I just don't approve calling it data recovery software because data recovery software should recover to someplace else, not to the drive that you're actually, your original drive and what it is. So those you just basically need to say no. Frozen drives. Now, a lot of people go, oh, this is a myth, whatever. It really isn't a myth. It does work. Unfortunately, it's not the best thing to do to a drive. If you freeze a drive, basically the idea is there's something that might, maybe the board or something like that is damaged or the contacts have, moved away from each other from heat or something. And when you actually are freezing the drive, it causes everything to contract. And then maybe you actually have a contact or something that will survive for a little while till it warms up again and it dies. But at the same time, you may get even condensation or temperature changes that may do damage to it. So if you're lucky enough to get it to work and you're going to do that on your own, you got like 10 minutes maybe before the drive might die again and you're done. So if you're going to try that as a last resort, great, but it is not a great diagnostics process to just like throw it in the freezer and hope that it's going to work when you're done. But if you got nothing else, I just don't approve of it. USB. This is another thing I hear all the time. Is everybody goes, well, I plug this into my USB adapter, I'm trying to recover data, blah, blah, blah. You guys might have forgot, but USB sucks. USB sucks. When you plug this drive into USB, the ATA command set is not really in its full capacity and running and doing what it can do. It starts up a driver in any operating system. It basically starts up a driver to talk to the serial port, and it's a mass storage driver. It's a generic driver. It has no real fundamental control, so you can't do error recovery and you can't do ATA commands that are going to give you any good response. So there's not a lot you can do there. Trust me when I tell you, drives you might have now you've tried to recover from by plugging into a USB adapter, if you go find a motherboard and you slap it on the table for $40 and you put a power supply on it and try to recover from it connected to an ATA command set, to a controller, to SATA or an IDE, or go buy a RAID controller and plug it in, you'll be able to read those better than you ever were through a USB adapter. So don't be going, oh, my laptop's all I have. Well, whatever. I'm just saying that that's not the best way to go. You could use eSATA if you needed to, but USB sucks. And these things, they're cheap-ass Chinese boards. Whoever's got, whatever the cheapest chip is today, and it's very, very simple stuff when they're putting it in these USB adapters or these USB external kits and stuff. You're paying like $13 or whatever for them. They're terrible. So skip those. Go get, you can even go on eBay and buy like an old Adaptec controller, like a 1200A, that's like $12 on eBay. And it will do a much better job at data recovery and error control than the crap that you're trying to use on USB. So basically, I want you to know you need to do anything that you're going to do for diagnostics with an ATA controller. There are some free tools out there that actually do some rudimentary, low-level diagnostics, like MHDD and Victoria. So again, I don't expect you to remember these things. Go hit the slides off my website, and those are the links to them, so you can go get them. You can switch from UDMA mode to PIO mode. You may actually get more. I actually did another talk on that, so you can go look at videos or whatever. And then you want to try reverse imaging in this process of actually trying to do something. So one of these tools for reverse imaging may work, and if you have money, spend it on a deep hard disk imager or another cloning machine or something. But in the process of trying to educate you, I want to talk about SMART as part of your diagnostics process, because a lot of people go, isn't SMART supposed to tell me that this drive is, bad or blah, blah, blah? Well, SMART sucks. You guys know this? SMART sucks. So I'm going to explain to you why SMART sucks. One thing, though, I want you to understand where SMART data comes from. It's very, very important to understand where the SMART data is written to from a diagnostics perspective and what it's doing, because it can be useful to you for diagnostics. It is useless to you in using your drive, but it may tell you a lot about the state of the drive, not because the feedback you get from SMART tells you anything, but the fact you could read SMART at all tells you something. So here's the story. So your hard drive has basically a little mini operating system on it. It's as complicated as anything that you know, even in a normal operating system or any other, car or whatever. It has similar post routines to what your machine has. But it goes through this initialization phase where it does self-checks, it does the spindle spin up, make sure that the heads unmount, and then it goes into reading what's called the SA area. So this red line I've got on the outside, it can be in a couple of places on the drive. Usually it's in the center, the outside edge, or it could be in the middle. So somewhere on the platter, you will normally have the system area. And so that SA area is very, very important because that's what we're trying to find out if the drive got through any portion of that so that we can say in our mind, well, I know where it was and what has happened. So let's talk about that for a second and what's in the system area. So the system area has smart data in it. So there's this extra little area that before you ever get to your user data, that these smart logs and this other content from the system area has to load. So it does not matter if you can't read your user data. If you can't read the smart data, in most cases, you're not going to get to your user data. Something else has happened, an exception has happened, or it has failed. So we have smart data. We have things like system logs, your serial number, and your model number. Now, this has changed since like 2002. Prior to 2002, you may actually get a model number or a serial number. You'll usually lose like a size, like it won't give you the geometry of the disk, or it'll say something stupid like 2 terabyte for a 40 gig drive or something. So it's important to follow whether or not your serial number and your model numbers have been interpreted correctly, even at a lower level when you're talking to a tool like MHDD. Because you can use MHDD to look at this damaged drive, and you can tell it, you can say Shift F2, and it will tell you what's my model number, my serial number, my drive, even if your BIOS never showed it. It's still possible to see it. So it's important, though, to know that the smart data is coming from that. So is things like your bad block list, your serial numbers, and your model number. So this is why Smart sucks. Smart thinks, it's supposed to be about predicting whether or not your drive is going to fail. But these numbers are just these arbitrary numbers that somebody made up and stuck into these for threshold numbers. And a lot of people don't even know what they mean or understand what they are. And when your drive is starting up and your BIOS sees it, the whole point is to boot very fast, to boot as fast as possible. So a lot of the extended checks are all turned off, so that you have a 5-second boot time or a 7-second boot time or whatever it is to make Windows boot faster or Linux boot faster or whatever. So it does a very generic check. It's not doing very comprehensive work at all. So, and in some cases, it's completely disabled. Like it doesn't even do a check at all. It doesn't even bother to tell you that this isn't working. The other thing is too, smart tables can actually cause the drive to fail. In other words, you don't need smart. It actually provides you nothing that you need to make the drive work, but it can stop your drive from working. The reason I say this is that the way that the drive works is it goes through, it loads the system area, it loads the content from these tables, and if the tables are corrupt, there's very, very little error checking that it does to say, hey, look, I didn't mean for this buffer overflow or something else to happen. It causes an exception failure, and the drive's code actually sees an exception and just farts all over itself. It doesn't do anything else at all. It just stops and basically freezes in time with a firmware failure because of the smart table. So data recovery people, the first thing they do when they hook it up to a piece of equipment is clear the smart table because we don't need it. It's worthless to us. It tells us nothing except that either I read it or I didn't read it, nothing else. So, and this is what it looks like. It looks like, just a bunch of arbitrary numbers. This is a tool called G-Smart Control. Some of you may have seen it before. You can go and find out what some of the things are that mean something. But again, warranty applies in a lot of cases. If your drive says I'm failing, you'll send it back to the manufacturer and say, your drive said it was failing, please replace me. Well, they don't want you sending it back. It's under warranty. It's going to cost them money. So there's a lot of numbers that have been changed maybe to make these thresholds higher than they should be, so that if it fails, that the manufacturer isn't paying for it. That's ultimately the point. How many people have seen that message that comes up on your screen that says, your drive is failing, imminent failure, please replace my drive, right? How many people have had a drive? So like 5 of you. How many people have had a drive fail? Wow. That tells you a lot right there. But when smart works, normally that means something really good to you. Think about this. You have a head. Is the head good? If the head read data from any place on the drive, you have at least one head that was good for the system area. You may have multiple heads, and maybe a head is bad. But one head for the system area had to go and read data from the system area to read the smart table to report it to you, which means I've at least got one good head, right? Everybody good with this so far? There's a few exceptions, but ultimately that's what we're talking about is we got a system area and a head read data, which means I probably have a good head, which means I might be able to read other data, even if I have another bad head that might not be able to read some data. And I'll explain all that stuff to you in a minute. But ultimately, my whole point is now I know to stop, because also what happened if the head read data from Smart and returned it to me, what else must probably be good? What? The controller, the board, the controller, and your firmware is probably at least running, right? You've probably at least made it through that part. So you already know right away if I'm able to read some Smart data, I may have made it further than, it doesn't matter if I'm reading user data, I may have actually been able to tell that the drive initialized correctly and it made it through this post routine because it will be one of the later things that actually happens. There are a few exceptions. Almost all of these exceptions have basically happened in the last year, year and a half. So I'm going to talk about these really quick before we go to the diagnostics component. First one is, everybody heard of Seagate 7211's firmware problem? Right? So there's at least 2, maybe 3 firmware problems that exist on these Seagate drives. We can fix at least 2 of them now. And when I say fix, we can't always make them work exactly the same way they were supposed to work, but we can make them work well enough to read the data from them, and then you throw the drive away, right? You guys good with that so far? Because the data is important, the drive is cheap, or should be. So basically, there's a firmware bug, and it can be fixed. And a lot of you probably know. Anybody ever had to send a drive to a data recovery company to fix this firmware problem? No, besides you. No, nobody knows, because you probably just don't even know. You probably just had, oh, a Seagate drive died, I mailed it off. And so they could charge you thousands of dollars to fix this firmware problem that there is a patch for. You can fix it for $25, okay? You can fix this problem for $25. Here's what you do. There's a cable. I even gave you the link to the cable. Go to the website, download my slides, click on the link, go to the cable. $25. There's your $25. Then you can go, and you basically have to get the firmware downloads. I have a web page that also has the firmware stuff up for the Seagate stuff. You are going to take this cable, and you're going to cut it, and you're going to connect it to a serial port. Now, on the back of all Seagate drives have a serial port that works just like a modem. You hook up these 2 wires, you start up terminal, and you talk to the drive through a serial port. It does not even need to be, and I don't mean the SATA interface, I mean there is a serial port. I mean a courier modem blinks at you, you unplug the cable, you plug it into, that's what I mean, literally. So I'll show you that in a second. But ultimately, these pins over here that most people didn't even know that would normally set your speed, which are usually set, by the way, to a default of limit my transfer rate to 1.5 gigabit. Not that you have a controller that can do this anyway, so it doesn't really matter, or a drive that spins that does this, unless you have solid state. But most of you didn't even know you probably had a jumper there that set that to 3 gigabit versus 1.5 gigabit. Anyway, that's what that jumper is. You hook up these 2 wires, the orange wire from that list and the yellow wire, and you plug this into a terminal. And you will be able to tell almost all diagnostics problems with Seagates. Whether you understand them or not is a different world. But you can see on a terminal screen what is wrong. The Seagate drive will actually tell you, I'm a Seagate drive, here's my firmware, here's my model number, here's my stuff, and it'll tell you that right there. And then if there's a repeating error, it will tell you what the error is. And there also is like a static. Now, when I tell you that there is a terminal and you can hook up a wire to it and you can see what's inside your Seagate drive, this is not a typewriter, okay? Do not just start, woo, I can write Word documents in this, okay? Because your drive will do things based on individual characters so don't just be like hitting random keys. I can tell you hit something like a period and it will give you a status line that it will actually talk to the drive, it'll say, what is your status? And it'll give you back a health line and it'll tell you everything it needs to know in one health line. Now you still have to interpret what that means. So, but all Seagate drives of all IDE, SATA, or 3.5, 2.5, they all have a serial port. This is going to be a small video on what this particular bug called a pending bug is. This is not one that you can fix, okay? If you see a screen that looks like this, when you physically hook up a cable and you're looking at your diagnostics, it's cool just to say it if you're just even doing diagnostics, but you cannot fix this problem. So if you see this, you know right away this is not something you can do. It will just keep looping through this process. Now what this type of bug is about 20 seconds after a Seagate drive is initialized, it will start going through doing checks to see what bad sectors are and doing wear leveling, shuffling bytes around on your disk. Yeah?
Just off topic, but can that serial cable read and write data to the disk?
You can really send commands to the system area or to a command processor, and you could like format reinitialize disk and stuff, but that's not its purpose. So you have to know quite a bit of commands. There's like 75 pages of commands. So there's a lot of things that you can control, but it's primarily for firmware. And I mean, you know, one other question that came up is, well, maybe I could actually write a little piece of malware and stick it in there so that when my drive. So there may be some plausibility to doing that, but it is not primarily for reading your user data. It is primarily for talking to the firmware and the what's called app code information. So in this particular realm, though, when you're dealing with this particular bug, it's called the pending bug. What happens is, if you were to try to copy a Seagate hard drive, and it would like read every other chunk of bytes, like you'll actually get, you know, bam, 120, then it'll skip 120, then it'll read 120, and it'll skip 120. This is normally called a pending bug. What happens is the data is trying to do wear leveling, and something went wrong in the firmware. And so instead of constantly reading your data and giving it back to you, it's tying up the processor. And the processor is trying to do this wear leveling process over and over and over again and will not be successful at it. It'll never end. And so you'll end up spending like two months trying to copy 750 gigs, and if you're able to even do it in 2 months. There is a way inside memory on the device to turn off this process. And as a data recovery company, we can read it, but we can't fix it. Like we can't like write it back to the drive and say, here's your drive back. We can read the data off by suspending the CPU pending bug, if you guys get what I mean by that. So that's one that you will not be able to fix, but you may be able to tell all this other stuff from a Seagate drive. Western Digital drives. Western Digital drives have one particular unique problem. Now, sometimes what happens is you think that the drive has a scratch on the platter. And because it has a scratch, you might want to open the lid and look at it to make sure. Okay, so we've all had talks about, you know, clean rooms and other stuff. That's a different conversation. But ultimately, the point comes down to, I need to check this drive because I'm going to buy donor parts. I'm going to buy another head, or I'm going to buy another board, and I want to make sure my platters aren't scratched. You can almost fairly safely look at every drive except Western Digital's. Do not open Western Digital drives because the head assembly is attached to this nub through the lid, and when you do remove the lid, it causes an alignment problem in the Western Digital drive, and then you can no longer read, even if it was an okay head, you wouldn't know that because after you're through dealing with your other problems, you won't be able to realign this head. It's very, very difficult and requires a special tool that looks a lot like this, and there aren't many of them, okay? And this is about an $800 tool to realign the head assembly, and it's still difficult to do, okay? So don't open them. Now, luckily for us, Western Digital drives, most of the time, both the new Seagate hard drives and the Western Digital drives are both almost always a firmware or a board problem. Anything made since maybe 2006, 2007, 500 gigs, terabytes up, any of those things are almost always a board problem of some kind. Not that there are no head problems, but they are rarer than you would think. They're almost always. Now, Western Digital has a new firmware board problem. They're not telling anybody, but it has a lot to do with this. They have basically like two filters on the board, and one of them fails, and then it can read 50% of a drive, but not the other 50%. So it would look like it's a head problem, but it's not a head problem. It's a board problem, and that's going to cause you another problem. So here it is. Everything that was pretty much made for Western Digitals that has a chip on it that's called a U12 or a U5. These are a serial chip that's on the board that stores the parameters that are necessary for this drive to work. They are unique to this drive. And if you are going to swap boards, you have to unsolder this chip and solder it to a new board. Now, most people go, oh, you're going to tell me how to do it myself, and that's really tough, crap to do. It's really not. It's not as bad as you think it is. I literally believe that you can resolder, never touching a soldering gun, resolder this chip, maybe with a practice board first. You can resolder this chip in under 30 minutes. You could learn how to do it, and when you're good at it, under 10 minutes. And if you have the right equipment, you could do it in under 2 minutes, probably. But U12 and U5 are the serial chips that store this data. You can unsolder. Now, there are other boards besides Western Digital that have these, but it's rarer for them to have them than it is for Western Digital. So the only one you can't do are the newer boards, the boards that have this shape. If you see this triangle shape, this is the one that I just described where Western Digital has a problem where there's these filters that fail, and basically you have to copy the ROM using a special tool off of here because you can't just unsolder it and solder it to the other board. So this is going to be one of the exceptions that you cannot fix So if you see this board and you think it's a head problem, it's probably not. But if you can read even 1 byte from that drive, even a single byte from the drive, you do not replace parts. You need to know what you got to do. And the tool that does it is fairly similar to this. And it is not a cheap tool. This actually is copying the firmware and the content from the board, and then we'll duplicate that onto a new board. So the way we fix this is we buy a new drive that works, that has the board in without the filters failing, that we can copy the whole drive. We take that board and we copy the code from one board to the other, and then swap the board. And then we can actually read it. But we basically destroy a good working, whatever, 2 terabyte drive in order to make that happen. We can put it back. We can copy the code and put it back, but there's always a chance of failure after we've done it. So, all right, so diagnostics. This is my fancy-dancy flow chart. Again, not expecting you to remember this, but this is a chart that you can at least go look at on my website. When you get to these red boxes, it usually means stop. If you do not get to the red box, then you might be able to fix this problem before you get there, depending on the drive. So what are we going to try to do? The very first thing that I want to do when I'm doing diagnostics, I want to hook this drive up to something that has an ATA controller, and I'm going to use a tool called MHDD. It's free. You can download it from HDDguru.com, and this is what we're looking at. There are actually in almost every, now see, like FTK Imager and stuff doesn't have this stuff. They don't show you these status lines across the top. You have a split in the status line. It looks like this. So you actually have statuses. You'll have things that look just like a courier modem. They basically say, hey, look, I've got drive ready, drive requests can be complete, and it can request data. But we also have status lights for failures. Every single sector that is on the drive has a breakdown for each sector that will actually tell you what's wrong, and it will respond to the correct equipment. Okay? So here is what a real sector looks like. What you know is a sector that you've been told for forever is a sector is lie. Okay? This 512 bytes is what you are copying when you are dealing with forensics. That 512 bytes down there is what you know as a sector. Well, the rest of this stuff is all part of the system, part of the drive, part of its functions. And they're all broken down into groups of data. So you actually have your addressing information, which is a particular type of error, and it will actually also go, depending upon how the drive actually stores bad blocks, it'll store bad blocks in another location. And then as you keep on going down, you'll have things like address marker not found, so you'll get something called AMNF errors or ID not found errors, depending on the type of error it is. So that will look like this. You'll actually see status lights over here on this side, over here, that will tell you what those are. So you'll get like abort errors, ID not found, uncorrectable, bad block, and there's address markers not found. Those are actually problems within the sector, but I've read content, but I have some other problem, okay? So I'm actually getting to a spot where I can read content, I've initialized the drive, and I can check it out. So in MHDD, you can actually just do what's called a scan. You can type scan at the command line, hit enter on this, and it'll basically go through, and if you can read sectors at all, or it reports any of this information to you, do not consider changing parts. Consider that there just may be a bad head or some other thing, and maybe we can still copy the data. What do I mean by that? There are some other things you can do too, like oscilloscope. There is an oscilloscope, and anybody use the oscilloscope, like a real oscilloscope besides a, yeah? So you can actually hook this up to the board, and you can find out in certain places what's wrong with this. There is some tools that actually have an oscilloscope built in that will watch the power consumption on the 5 and 12 volt channels. So you can see things like, oh look, my head is jiggling back and forth as it's trying to initialize. Here's my motor, and it's spinning up in a power, and I should see, it just depends. So in this particular case, I can tell this is a 3.5-inch hard drive because I have 12 and 5 volts. If I have a laptop drive, I'm only going to have 5 volts. So there'll be certain things like that where you can actually use an oscilloscope if you want to kind of graduate through the electronics components to tell that. But I can actually tell if a processor is in use. Like you can actually see when the processor utilization goes up based upon it reading a sector and stuck in that pattern. So again, pay attention to serial numbers, model numbers. If you get even this far, where you actually see, like you guys have probably seen this before, like you mount a hard drive in Windows, you don't get like, hey, I got NTFS or something over here, but I get a partition structure in a drive. Well, I probably made it through the system area, probably made it through the initialization, and if I'm getting a partition and the size actually looks like the size of the drive based on the sectors written on the lid, I'm probably in pretty good shape. I can probably do logical or figure out what's wrong with the sectors and why I can't copy them. But it may be like a memory board on the physical drive that actually is failing. I could copy them in reverse. So that tells you a lot about whether or not your board is working and that you've made it through this process. There's one other thing, too, with regards to how does firmware work. So let's say, is my board working? I want to know if my board's working, but maybe firmware and other things have a problem. And it'll start to come together for you in a minute. So I'm backing up and I'm saying, all right, I did not read data. I did not get smart. Is my PCB board working? Is the printed circuit board on the bottom working? So if the board is working correctly, it will try to send the head to the system area to read the content. Now, unfortunately, except for Western Digital's, you'll have to open the drive to actually see this. This is what it will look like. Now, this movie is going to do it twice. You'll see this process twice. But understand, I got a drive that does not return data to me, and I want to see if the board is working by sending the head, without expensive equipment, by sending the head to the correct location to read the system area, and then I'll know that it failed at that point, that maybe I've actually got something else going on, like click, 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 or something. All right, so here's this video. It'll do it twice. The head will move to this location, and it will jiggle back and forth intentionally. Now, you'll see it in a second. It'll park again, and it'll do it again. But the head will actually go to this seek area, and it'll jiggle just the ever slight so much. And you'll actually see it, like, read the data. Did you guys see that? So that actually read the system area and then responded to me before it actually went to its park location. So I know where that system area is on that drive. Now, if you open up a drive and you see something that looks like this, well, it probably kept sending the head to that location, but there is some damage, and then it scratched the platter. So it never was able to read the system area. That's probably the system area, and that system area is gone. So it's very, very important to at least see it go to this location and intentionally jiggle. If it doesn't work, what will happen is you'll get click, 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 and it'll never actually look like it went to the right location to read any data. But the very first time that it's powered on and it goes through that initialization process, it's got to go try to read that system area. So when you're dealing with things like that, which are head problems where you actually have a head crash, there is a difference in how the head actually responds. So here's an instance right here where, okay, so you've got a head that clunks and you have a head that clicks. And I'm serious when I say this. Like, you guys have probably heard click, click, click. And you've heard clunk, 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 right? That is probably a bad head. The clicking noise, it may not be a bad head. So here's an example of what that sounds like. This is an older drive. Now, that's a severe one. You probably haven't heard one that severe, maybe. But so ultimately what ends up happening is something around 3 minutes, maybe 3.5 minutes. If the other heads are okay, it's kind of bad to let it run like that for 3.5 minutes, but I'm just telling you, you got no equipment, okay? So somewhere around 3.5 minutes, if the other heads are okay and they respond, they may read the system area and then still return the data to you. You may still get a serial number or a model number if you were letting it run until it actually settled down, and you will actually be able to read content. That means that you probably only have one bad head. That means you may still be able to read the other data. And you'll understand why I'm saying this in a minute. But you know, there's this idea that, oh, my data is written consecutively through all my platters and divided up bit by bit through the platters. Well, that's not true. Every head writes data, and then it has to be turned off at some point, and the next head has to be initialized, and then data has to be written there, and so on down through the head stack. So data is not written all in the cylinders across all the platters. It's actually divided up into what's called zone tables. So this is what it looks like, though, if you actually have a bad head. You might be missing one altogether. So that clunking noise came from this drive. Now, all the other heads were fine, but this one. So now if I'm going to try to read the data from the drive, yes, I might need to replace that head to read that platter, and I did, and it worked. I was able to do all but 4% of the drive. But I can still read the rest of the data. So before I replace a head, I want to image the rest of the data I have, and I can turn off this bad head with some equipment. You may still be able to read it even without that. But this is why I can still read the data from it. This is called a zone table. So on the drive, in the system area, they said, what is the fastest part of my drive on my platters? And so from 0 to, in this case, 4,300,000 or something, 4,326,000, blah, 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 LBAs are all on one side of one platter. So I got basically like a chunk of 2 meg of data before it moved to another location on another platter. So if I could read, say, 75% of the disk, I may still have Word documents or pictures or something else that I can still interpret. Then I can go and fix the one bad head and then fill in the hole for the one that I read, if that makes sense. So what it looks like is this. So If I was to sequentially read a drive that had 4 heads and one of them is bad, then in this case, you'll actually see green, green, green. I was able to read all these sectors. Then I got a chunk where it's bad. It didn't read any of this, and then it continued on. Well, I might be able to read all that data, interpret it. So for instance, in this particular drive, I know you guys can't read that number there, but that first place where it actually starts off and it's bad is 409600 is the location. Now, the MFT is normally stored in a smaller beginning area of the drive. So if you have the MFT, you might be able to determine what the files were and where you can go get stuff. So if the MFT is in the green, you may actually be able to tell where your files are and skip some of the locations of where this bad head is. If you have a Mac, well, the table actually starts right in here, 409.640.42. So in this case, the actual table, which would have been the catalog, is destroyed. So I actually will need this head in order to get files back other than carving them. Otherwise, I'll have a problem. But you can know a lot from just looking at that type of information. So if I have to replace the head, I could actually go through the process of reading this. Then this is actually where I actually start physically like disassembling, reassembling drives. I use a foil head tool. Now, some people know these things to be like head combs. There's a tool that's called a head comb. You can slide in between heads and you can remove them. I use something similar to a Sudafed container, and I can make them out of this for like 50 cents. And you know, it's really rough too when you go to the store and you go, look, I need 50 boxes of Sudafed. When you're teaching class and you want to, you know, oh, I got 7 FBI agents in my class and I need anyway, maybe somebody can make a phone call and get you some Sudafed. Anyway. So ultimately, that's where we're dealing with, okay, I've been able to read the other 75%. Now if I replace this, I might be able to read this 25% and put that back into that location. Now those are a little bit more advanced methods, but it is possible to be able to tell that I have a bad head, still read data, and return something, and then fix it myself. Now there is one other problem that's very simple for you to fix, which is, anybody heard Star Trek sounds on their drive? Anybody hear phasers? You probably heard it, but you don't know you heard it. Okay. Here's what it sounds like. Nobody's heard that? Yeah? So normally what this would mean is that I've got a head stuck to the platter, or I got a spindle that doesn't turn, so the head's cannot read anything, so they'll make noises like this. So here's another one that you might have heard that's very similar. Anybody heard that? Yeah. So normally that means I've got a spindle that's not turning, my head is stuck. And in some instances, like for instance, there's some laptop drives that are like 80 gigs, that the head is stuck to the platter. All you literally have to do is open the drive itself and turn it with a screwdriver without touching the platters or scratching the platters. Turn the platter till it breaks the torque. It's called stiction, basically. We used to have this problem back in the early days when RLLs, MFMs, and stuff like that would actually stick. And what was the fix for it? Anybody remember the fix for stiction? Yeah, screwdriver, right? It was, right. And Secretary, my machine doesn't start up. Start it now. All right, awesome. Or you take it out and you spin it on the table in the opposite direction. That would do it too. But in this case now, they're actually really stuck. Now, the exception to this is that some of the newer Seagate and Western Digital hard drives that are now like in little mini towers and they're standing up on their end and you know you jiggle the table and they go boom, right? Now what happens actually is that the platters are so heavy, in a lot of cases the spindle will break free. And the spindle inside the drive will not turn anymore at all. So if you open up the drive and you're not able to turn it at all, and the platters don't spin at all, then your motor is seized, and that's a more advanced replacement at that point in time. But if it does turn at all, and you can break the head free, you will probably be able to read your data and do okay. So there's one other really simple problem. Anybody plugged in like you get a Seagate 640 and you plug it in and all of a sudden, you know, it just doesn't power up at all. You hear nothing. No spindle, no nothing, no head movement. It just sounds completely dead. You guys had this one? So there's a lot of these that are actually just like this, like no power at all. You don't hear it spin up and you're just like, it's dead. I don't know what's up. Well, they have a voltage suppressor on them. Anybody remember the keyboard fuses? Remember back in the early days in the ATAs and XTs? Yeah, some of them are older. All right, so, and how'd you fix the keyboard fuse?
Jumper it.
Yeah, you jumper it by stick a penny in it or something like that, right? So the keyboards had a fuse that if they blew, rather than blow something on the motherboard, you actually would have to resolder it on the motherboard itself. to prevent the motherboard from dying. Well, on hard drives these days, you'll find these on the bottom of almost all of your 3.5-inch hard drives. There will be these two fuses. Now, basically, these suppressors. There's one, the smaller one, it's 5 volt, and the bigger one is 12 volt. So if you got 5 volt and 12 volt, now, I'm not just saying, let's go rip these off, okay? You know, you might, if you have no other alternative or you can't find a meter and test them, there is an option. It really won't do much damage. Almost all of these are near the power supply. So here's the power. Does it really get anybody that the power is like a lot wider than the serial port itself? I mean, like, what the? So the power itself, it will be by the power, it will be near the power, and you will see one of these two types of configurations that maybe will be sitting around somewhere with a smaller and a bigger one, and literally, you snap those suckers off, and the drive will spin right up. Now, most of the time, it's because you had a crappy-ass power supply. You got that? Your crappy-ass $50 power supply that you didn't want to spend $169 from some really nice, Cool Max or whatever, blew this thing, okay? You can tell a power supply by weight. If you can pick it up and it's like, ugh, then you had a good one. If you can pick it up and it's like, oh, this is light, it'll be easy for me to carry. That is not good. Spend the extra $50 or whatever. Here's another thing. If you rip these off, don't plug it back into that power supply. That's probably the end of your drive. You will actually cause it like, oh, it didn't spin up again. No shit. Really, you just fried the damn thing now. So that's what's going to happen to it. You're going to blow the preamp on the head assembly or something. It's going to blow. So plug this into something else, okay? Get something a little bit better that you're working on your workbench or something like that to at least try to at least make sure that you can read this. But that's bad news. So on your electronic stuff, how do they basically burn? I'm going to go a little faster here for a second. This is what happens when you plug one in backwards. See down here in the corner? Smoke, fire, blah, blah, blah. That happens all the time on Mac store drives. It's a very convenient thing that the chip will burn. And this is the motor control chip. This chip basically will cause the motor to spin. And without that chip, it won't work. So you could just swap this board, but if you needed to, you can unsolder this. Sometimes it's not that obvious. Most of the time, you can tell by... Okay, they cut me off. They said, you're done. And, oh, well, I'm the last guy, right? Do I get like one more minute to finish up?
Oh, no, actually, there's a question, or two questions from the guys in the streams. First question is there a link, or do you have a web page or a single source where they can get all of the tools that you referenced in your slide about 4 minutes in?
Yeah, if you go to myharddrivediag.com, so the question is whether or not, and I don't have a mic anymore, so if you go to myharddrivediag.com, I have all the information for everything on there. So there'll be a presentation page which will have all this and all the information for the slides, and I have text in the slides in the bottom and stuff that they'll be able to read or something, but that's about it from that standpoint. But I do have other content on the page that videos and movies. Yes, sir. Next question?
And second question from the streams is how much of this technique base applies to solid state drives?
Not very much of it. The only part that really applies to solid state is similar to this resistor problem that we actually have where we have like a transient voltage suppressor. USB memory sticks and a lot of the solid state drives will have a similar resistor pack on their disk. The problem is that when they blow, they're a lot smaller and harder to find, so you really have to use a meter to test them. But in some cases, the exact same thing applies where you can rip them off and then the drive will work correctly. But as far as the rest of the content applies, other than I'm going to solder something, nothing much. It's a much more complicated recovery for solid state stuff, and that will be coming up in one of my other future. I have a previous solid state presentation. It has become more advanced than that, and I will eventually have another one that will tell you how to really do it, but there's only 3 people in the whole world that can. Okay, anyway. Yes, sir?
Technically, it's not that a question, but I wanted to ask you, since you have extensive experience with hard drives, I noticed in the standard there are 2 commands to make a drive white mixer.
Yes. So the question is basically about the secure erase, and there's 2 versions. There's an enhanced secure erase and a standard secure erase. And your question with regards to their existence is?
That the second one supposedly would wipe with random data.
Yes.
My personal experience, it only puts zeros, like the first
No, the enhanced one actually does use randomized data, and it actually does do. So you may have actually still run the first version or something. When you're running the enhanced, you should get two choices. Like if your drive supports it, you'll get the standard one and the enhanced one as two choices on the menu. And the enhanced one does, and I have tested it, does randomize data and does put a pattern of random data in different orders on the drive. But I'm not sure what your problem was with that, but there are some issues with regards to motherboards. Like Intel motherboards freeze the command so that the command can't run correctly, and so you have to do like this cold boot trick in order to get around them. Send me a more specific email or something, but they do work, and I do have a previous talk about those. I did Shmoocon last year, top 10 things about hard drives, and I did it on that. Yeah. Yes, sir. Next. Right in front. There are some like TPMs and some black armors and stuff that can do that, and so you're right that if the key is like erased or wiped, but not the standard traditional drives that are still sold on the shelves. They still actually have to go through the whole process, but they're fairly quick at it. But they don't just erase the key. But some of the newer encrypted ones have some other alternate methods. I can still read the content from them, but I can't decode it. Yes, sir? Because the size was wrong? It says that this... Right. Yes. Okay. So there is a way to copy the serial number. What he's asking is he cloned a drive, but he had maybe some software that was dependent upon a serial number on the drive, and that something happened with the software not recognizing or something not recognizing the serial number correctly, or even things like Windows. Sorry? So yes, there is a way to do it. However, it does require a tool that can talk to the system area. So most of the tools are fairly expensive. There is some low-end tools that I have seen called pokers. So if you do a search for a poker, there are hard drive pokers. I am not condoning, piracy in any way, but I am saying that there is a way to actually duplicate a serial number and a model. You can even make like a model number change. You can make a 40 gig look like an 80 gig or whatever, but you can change those, and I've done so before. But you can duplicate that. You can even back it up. Yeah. Anybody else? Yes, sir. That's a lie. Well, okay, so he asked about life expectancy of a drive, maybe high-end versus low-end versus whatever. Bye, Scuzzy. Everybody else's drives are all cheap and crap, and even the Enterprise editions are, in my world, still not good. They have a lot to do with the components, how long components are baked, and those kind of things. But the mean time between failures is a complete arbitrary lie. If you do a search for it, you'll actually see that they actually even declare it as a lie, that they've never run a drive that long or even attempted to run a drive. They take some mean sector failure based on some older stuff. Now, in 2006, they changed drive manufacturing processes, and so the newer drives fail at a dramatic rate. The newer stuff, to me, is failing like, you buy 3 Western Digital drives, they may all be dead within 3 weeks of each other. Same thing of, Seagates and stuff like that. Hitachi right now seems to be the leader for me right now. It changes like every 6 months, though. But Western Digital has a real firmware problem right now that they don't seem to be openly declaring is a problem. Don't sue me. But it's there, and we know about it, and so things like that. No, I would say that new drives fail. You have no predictive rate for failure. It will fail in a week, 3 months, a day. It could be any number of things with regards to even problems with the firmware stuff currently on the new ones since 2006. Prior to 2006, I might have given them 3 to 5 years. Prior to 1999 and 2001, I would have given them 5 to 10 years, but not now. The new stuff, I don't trust at all, period. RAID 6, RAID, Mirror, anything else but that. Or Seagate, or SCSI. Yeah.
Since stuff changes so often, can you tell us briefly what the current situation is with the Seagate drives that have gotten a bad rep, the 7200.10?
Okay, so they have, Seagate has a fix. He's talking about the firmware problems for Seagate. Seagate has a fix for their current existing problem. So for instance, if a Seagate drive is still operable, it can be updated, and the firmware can be updated just by getting their utility and updating it, and it will work fine from then on. If the drive fails, then we actually have some tables and a short that actually has to happen on the board in order to actually repair that. And it doesn't quite do exactly what you would expect. It's not like a perfect fix or repair. And then there is some third firmware problem. So we can read the data in those other two instances, but there's this new introduction of a third firmware problem that nobody has correctly, completely reverse engineered, or we don't have a large enough subset of the drives, but they do still fail, and we can't recover from them. And so far, even the drives that I have forwarded on to Seagate and their own data recovery company, conflict of interest was what I was going to say, but they cannot repair them either yet, as far as I know. So nonetheless, right now, there's still some other problem that has been undetermined. Yes?
Worst brand and best brand.
Well, that changes. Worst brand and best brand changes and alternates. So, in 2003, we had a bad problem with, Death Star drives dying on a daily basis, and now we have Seagates. Now I know of a Western Digital problem, and right now Hitachi seems to be, which is the IBM Death Star drive, seems to be the better one right now. So it rotates like every 6 months. I seem to have a different opinion of what that problem is for today. But they're all bad. They're all bad. They're all bad. Make sure you have duplicates, backup, redundancy, anything. Just trust me. I would be fine if you guys put me out of business and I never have to recover a drive again. As long as you do good backups, let's have good quality, please. So, anybody else? He's calling. Oh yeah, go ahead.
Actually, two questions from the streams. First question, in your opinion, what's considered secure in terms of software wipe? They were asking in terms of number
Right.
of months.
This is back to the secure delete, secure erase question. Basically, what is secure and why is it secure? You have to understand that when you guys are using like DBAN and things like that, it does not wipe bad blocks. I have actually taken drives that were certified by other companies that said, hey, we wiped it and we certified that it's erased. And all you have to do is clear what's called the bad block list, the G list, and then you can read from the sectors that were originally written to, because remember, 512 bytes was written, then it was determined to be bad, then it was moved to another location. DBAN wipes the other location. It doesn't wipe the original location. So if I clear the G list, I can read that content from those bad blocks. So the only secure program at erasing drives is the one that's part of the ATA command spec, which is done by the Center for Magnetic Research and Recording by Gordon Hughes. And so if you go to Center for Magnetic Research and Recording, you can find his tool, and it is part of the ATA command spec, and it will actually ask the drive to erase tracks and does it complete by comparison to what something like DBAN. DBAN makes requests through your computer, through the API, through, back out to the BIOS through the device. The ATA command sends it directly to the drive processes it on its own. It does it in phenomenal time. 500 gig drives are erased safely, getting rid of those bad blocks in about 2.5 hours.
12 gig slow, a lot better.
What's that?
12 gig slow.
Yeah, if you want to shoot them or something like that. The other thing that keeps being asked is about demagnetizing a drive or using a demagnet. If your drive still operates after it has been degauzed, it is not correct. Okay? You did not degauze it, okay? So it